The demand for higher data rates and lower power consumption has tightened requirements for high-speed semiconductor devices. To address power and signal integrity challenges, Noisecom J7000 and JV9000 noise generators enable real-world evaluation and tolerance testing to ensure these components can be powered correctly and function at high data rates. Lower supply voltage level requirements are greatly impacted by external and internal interference, or system noise, increasing the importance of testing noise on voltage rails, or VCC. The Noisecom JV9000 can stress chipsets by generating a user-defined noise band and center frequency, which is added to the clean DC power supply received as input. The new noisy DC level supplies power to the DUT, where a clock is feeding a buffer amplifier with its output viewed on an oscilloscope. When utilizing the JV9000, the oscilloscope shows a significant increase in jitter on the rising and falling edges, simulating the impact of real-world interference on the system. High-speed semiconductor devices and serial data communication links must deal with faster speeds and small form factors with tight spacing, all while minimizing bit error. To test jitter tolerance, the Noisecom J7000 can add random noise to a serial data signal generated by a bit error rate tester. Viewing the output on an oscilloscope, a clean signal with minimal jitter appears without engaging the noise source. The oscilloscope's eye diagram may shrink when jitter is present on the signal, enabling a better understanding of DUT performance to effectively guide design improvements. The Noisecom J7000 can also generate crosstalk to measure the impact of interference, such as noise from nearby traces or noisy components on the serial data link. In this example, a bit error rate tester generates a serial data signal for DUT evaluation. The output of the oscilloscope shows a clean eye diagram with minimal jitter when the noise source is switched off. However, when the noise is added to the DUT to test its response to system crosstalk and interference, the results reveal compliance test issues. To test multiple power and signal integrity issues simultaneously, designers can use the Noisecom JV9000 and J7000 together during testing. In this case, a bit error rate tester generates a serial data signal that is fed into the J7000 for jitter tolerance testing, which is connected to the DUT. At the same time, a DC power supply that's powering up the device is being fed through the JV9000 noise on VCC generator. Viewing and analyzing the DUT output on the bit error rate tester, engineers can analyze system performance as it relates to noise on the power rails, jitter on the data lines, or both at the same time, giving a complete picture of how the system will operate in the real world. To learn more about noise source solutions that address power and signal integrity challenges, download the Solutions Guide from Noisecom. Subscribe for more content, and thanks for watching.